Welcome to Zero Knowledge. I'm your host, Anna Rose. In this podcast, we will be exploring the latest in zero-knowledge research and the decentralized web, as well as new paradigms that promise to change the way we interact and transact online. This week, Kobe and I chat with Trent and Carl from the Ethereum Foundation. We chat about their work on the KZG ceremony and dive back into the topic of trusted setups. We cover what they're for, how they've been run, and then look at how this ceremony is different from the previous ceremonies we've covered. Before we kick off, I want to let you know about the upcoming ZK Summit 9 event happening on April 4th in Lisbon. Once again, we bring together the top teams and researchers to talk about their latest work and the most cutting-edge implementations in the ZK space. So mark your calendars, apply to attend, and join us. Now, Tanya will share a little bit about this week's sponsors.
Aztec Network is building a next-generation encrypted blockchain powered by Ethereum. The team is proud to announce Noir, the world's first universal ZK language. Noir makes it safe and intuitive to write ZK circuits and encrypted smart contracts. Aztec is now hiring engineers and cryptographers to build an execution layer enabling scale and privacy for crypto applications. Join the team making encrypted Ethereum a reality. Learn more by visiting aztec.network/careers. So thanks again, Aztec. Anoma's first fractal instance, Namada, is launching soon. Namada is a proof-of-stake L1 for interchain asset-agnostic privacy. For privacy, Namada deploys an upgraded version of a multi-asset shielded pool circuit, otherwise known as MASP, that allows all assets, fungible and non-fungible, to share a shielded set. The MASP circuit's latest update enables shielded set rewards directly in the shielded set, a novel feature that funds privacy as a public good. Visit namada.net for more information and join the community on Discord at discord.gg/Namada. So thanks again, Anoma. And now, here's our episode.
So today we're here with Trent and Carl from the Ethereum Foundation. Welcome to both of you.
Thanks for having us on.
Thanks for having us.
I also want to welcome Kobe, who's going to be co-hosting this one.
Hello.
So today we're going to be revisiting the topic of trusted setups. This is a topic we have covered quite a few times on the show. I will add some links in the show notes to the previous episodes. I mean, I did one full episode just on trusted setups 2 or 3 years ago. It's going to be kind of fun to dive back into it. Today we're going to be talking about the KZG ceremony, which is a ceremony initiated by the EF. It's kind of a unique episode because we're actually doing an episode on it while it's running. So that's a new one. I guess anyone listening can actually potentially participate, and we're going to find out a little bit more about this. So maybe before we kick off into all of this, it would be great to get to know you two. Trent, why don't you tell us a little bit about yourself, what you work on day to day, and why you're working on a trusted setup?
Sure. So I've been in the crypto space for a couple of years now, since about 2016. I used to work in architecture and design. That's what I went to school for, and that's my training. Got into Ethereum and pretty quickly fell down the rabbit hole and worked at a couple different companies like ETH Global, White Block, and then eventually made my way to the Ethereum Foundation, where I do network coordination or upgrade coordination. So, for example, 1559 and the merge. These are the sort of things that I'll be getting the community to engage with, helping them understand what these protocol changes are, helping them engage in the process, things like that. So that's what I'm doing day to day. And then this is sort of a special project, the ceremony, that we've been working on since last May, I believe.
Cool. And what about you, Carl?
Yeah, so I'm a researcher with the Ethereum Foundation, mostly focusing on the proof-of-stake side of things and all the fun challenges that go along with it. I've contributed a lot to the specifications that is now Ethereum proof-of-stake. And I guess my speciality is focusing on side projects, or like not the primary research, not the main specs, but things that are very important to the ecosystem but need extra work. So, for example, the Launchpad, and all the deposit flow for validators, I think many people would be familiar with. I did a bunch of work there and on wallet standards, et cetera, et cetera. And now my latest focus has been on this KZG ceremony and 4844 more generally.
Is this both of your forays, it's like first forays into ZK land? or had you been doing stuff like this before?
No, I've never worked on a trusted setup before. Well, I mean, I've participated in them, but not.
Okay.
I haven't run one, or no.
I mean, in terms of doing anything beyond having discussions,
Learning?
Sure, yeah, exactly. Learning, the lots of discussions with my fellow researchers in the EF and other people in the space, trying to understand all the latest protocols and how we can apply them and tweak them and improve them. But I guess this is my first output that would be meaningful to most people.
Cool. One side note, Kobe and I, we've mentioned this a few times on the show, but years ago we co-ran. I mean, Kobe really built a lot of this. I helped. And we actually had some other folks with us as well, but we co-ran a trusted setup. And Kobe, I was just thinking about that trusted setup. So this was for Plumo. That went on forever.
Yes.
That was like a year.
Oh, wow.
and it was, I think, let's say orders of magnitude less participants than there are already in the live KZG ceremony. But there are good reasons. We can talk about that.
I'm really glad we did that, though. I mean, it just kind of gave, for me at least, it was real insight into what it means to run one of these things. I want to talk about the KZG ceremony. What is this ceremony? Maybe starting from a person who's potentially wants to participate in one of these things. Where is it? What is it? What's the plan for it?
KZG ceremony is, if we're thinking about it literally, it's an event that goes on for a couple months, or at least it's planned to, and it is literally the Ethereum Foundation hosts a sequencer which passes data between a number of participants. They perform some computation, send the data back to the sequencer server, and then you repeat the process until we hit a time limit or the output has been judged to be sufficient in some regard. So that's literally what's happening. There's just data being passed around and you perform computation locally. But if you think of it more from a high level, ceremonies generally are about coming to consensus on a process. The same thread you'd see in consensus mechanisms, how they're trying to come to consensus on the head of the chain. There's people participating and there's incentives and things that people are trying to do possibly to corrupt it. It also fits into that sort of area of crypto broadly, where it's this group or distributed community of people who are trying to come to consensus on this, in our case, a string of data. And so there are a number of things that you can do to improve the process around coming to consensus around whether this string is legitimate, whether the process to create this randomness was credible. That's maybe more of the high level perspective. Yeah.
And I think listeners of this show, I've mentioned this a few times. So the thing that these ceremonies are trying to output is called an SRS. Can you tell me what does that stand for?
The structured reference string.
Yeah. I think every trusted setup, every ceremony will output something like this. The SRS is meant to be public, but every contribution that you just described from individuals is meant to be private.
Yes, it depends how you define contribution here.
Okay.
So people add a secret, some randomness to the file. That is meant to be private. But then they contribute to the ceremony or add a contribution by mixing in this randomness with everyone else's contributions.
The way that I like to look at it, which is that, every participant gets the current SRS, right? And shifts it a little bit in a way that the others can see. And then if you have one that does not reveal how they shifted it, then everything is secure because we can predict that shift.
You just mentioned a sequencer. In other trusted setups, we usually had something called a coordinator. Are we talking about the same thing?
Yes.
Why the name change?
Actually, not sure. Carl,
Is it because
knows.
there's sequencers and rollups, maybe?
No. That's almost an unfortunate
mistake. Okay.
Yeah.
Okay.
After the fact. I think it's more just to not overemphasize the power that this entity has. They're not some privileged entity in the space. And in essence, all they're really doing is deciding who goes next. So they decide on the sequence of things. Coordinating sounds a little bit more like there's someone pulling the strings in the background.
I see.
When this person really this entity server really has much less power than that.
Yeah. I guess sequencer is more of a passive framing of just okay, we take stuff, we pass it to somebody else. We're not I guess, I mean, obviously there is some coordinating type activity happening, but maybe it's just a personal choice. Not personal, but like we just sort of settled on that.
Yeah, actually, I'd love to dig a bit more into like the role of the sequencer here, because I think that in different setups, the sequencer or the coordinator had different powers, like you say. And when we look back at the original setups, like the Zcash setup, there really was a coordinator, and it was Sean or someone. Eventually, it was Jason, I think. And that person actually chose who goes next, and that went through a mailing list. And there was kind of this assumption of if, someone gets censored, or, if the Google mailing list hides the messages from someone, they can make a public outcry and they can get like included in that way, right? And this came up to me because you were kind of equating it to consensus protocols in some, like for some analogy. And maybe there is a bit of difference because the sequencer is even less trusted, where in consensus protocols, maybe you have more power to censor or whatever.
Yes and no.
Okay.
In that one of the hard things about consensus protocols is deciding on the order of things, because different people have different views, different nodes have different views of the order that messages came in. So it's the reason we end up with short-term forks on chain, is because from different perspectives, it might look like one version of reality, and from another person's perspective, another thing. And they're both maybe honestly telling the truth as to what they saw happen.
Right.
And then the consensus protocol like helps realign things. Yeah. And so what's happening in the case of the sequencer is we get rid of a lot of those problems by having this entity that decides who's going next, in essence, what the order is. So
Right.
they're like, in some ways it's less trusted, in some ways it's like really helps out promote the protocol here. And would like, it wouldn't be a design that would be okay within a standard blockchain consensus setting.
Right.
Given the amount of participants kind of already in here, I'm assuming the sequencer is automated, right? Like there is no person anymore at the other end.
Yeah,
like,
no.
There's nobody clicking a button right now.
except
Next.
I mean, I think like right now there are like 4,000 people in the lobby, so that would be a lot of clicks.
That would be a lot of work. Actually, now I'm curious, and we probably did cover it on one of those episodes years ago, but what was the first setup to automate the coordinator? Was it the second Zcash one, or was it a later one?
I don't think the second Zcash was also automated, actually.
You think that might have been manual as well?
I think so.
I believe Ignite must have been automated, right?
I think Ignite and Tornado.
Okay. A Tornado for sure, because that was like a 2-minute one online.
Yeah.
Right.
Were there any others that you've looked at while designing yours?
We did. Yeah. That was because I was completely coming from, starting from zero. So I did quite a bit of research. I've probably forgotten a lot of the like little details and specifics, but yeah, that's what I did mid last year, was kind of trying to get an overview of everything that had taken place before. Interestingly, this isn't one of the things I looked into, as whether the sequencers are automated or not.
Okay.
It's been interesting is like lots of these details aren't super obvious in some of the previous ceremonies. It's not
really hard to find all the specifics. Yeah.
Yeah, even just simple-ish questions like how many powers, or like exactly what the calculations look like. Those kinds of things. You got to go digging in code and old GitHub repos and that kind of thing in order to understand this.
So in some of the later ones, or like the more recent ones, there's sort of this like parallelization. This is what in the Pluma one that we did, we had like multiple participants running it at the same time. And I'm just wondering, with the one with the KZG, is this fully like sequential? As someone's contributing their entropy and their contribution, you cannot have anyone else contributing at the same time?
Well, so they can generate the entropy beforehand, but doing the computation has to be sequential.
Okay. So it really is like, basically there's a participant adding their contribution, sending the baton, the sequencer then sends it back to the next participant, and that just continues.
Yeah, so and we can get into a bit of the design philosophy later, but what some of the other ceremonies have done in the past is, say you have 1,000 points to calculate.
Yeah.
You do pipelining. So as you've processed the first 100 points, you send those back, the sequencer starts verifying those and passes those on to the next participant. So you don't, like, although it's a sequential process, you can sort of break up that sequence. But a little bit of the way we've tried to design the ceremony and some of the unfortunate things we've had around the requirements of the ceremony means that the benefits we'd get from doing that are relatively small. We gain other things by not doing so.
Yeah, actually, in Plumo, we did even something a bit more complex where, one participant works, let's say, on the first chunk of the ceremony and another works on the second chunk, and then they switch places, and then that one works on the first and that the other one works on the second. So it's like out of order execution. But like we can talk about the parameters later, but yeah, in the KZG ceremony, like it's so fast. How much time does it take to contribute even? It's not really useful to do this chunking.
No, that's exactly it. So I mean, in browser, we have multiple implementations of the software you can use to contribute. The one in the browser was in Blob running Rust code under the hood. That takes something on the order of 12, 15 seconds.
Wow.
And if you do it from a CLI on my machine, some of them are sub 1 second to contribute.
Wow.
I don't remember exactly how to word this, but when you talk about this very short duration, I'm assuming this has something to do with like whatever the size of the circuit or thing that you're using this SRS for is smaller. And I realize I might have worded that wrong. So yeah, why can it be so quick?
So in this setup, we don't actually have a circuit because this is not a traditional ZK application. Instead, this is just a commitment scheme. So we need like almost the precursor to before you put it in a circuit. We literally just need the powers. And by powers here, we mean some secrets, secret squared, secret cubed, literally like powers as you'd think in high school math. And fortunately, the way these KZG commitments scale relative to our needs and relative to the needs of EIP 4844 means that we only need very few powers. So some of the previous ceremonies, which have been for ZK setups, have had, for example, 2 to the 28 powers. In our case, the setup we really need only has 2 to the 12 powers. So only 4,096 powers of tau.
There were also, I mean, there was a really complicated setup where, like for Alio, where they did different setups for different parts of a snark. In this case, is it just a single setup for a single part of a snark? Or will there be like a second one? Is this one in a few?
That's what you'll usually see as like a phase 1 and a phase 2. And Carl, correct me if I'm wrong, but I believe we're just doing the phase 1. There's no circuits that happened in the phase 2 part of the ceremony.
So like in many other trusted setups, you would do basically first a powers of tau setup or something very similar. And then you would fine tune it after that to be specific for your use case, depending on your proving system. In the case of the KZG commitments, we don't need that second phase. We can directly use the powers of tau.
One question is, why do this setup? Like, there are a lot of setups that have been done. There's SRSs that other projects could potentially use. So like, why do a new one? Is it so unique? Does it have some characteristics that the others don't?
I think an important thing to acknowledge here is aside for it's a bit fun, you should really avoid doing a ceremony. It's like always a potential point of failure resort in the protocol. Yeah, exactly.
Yeah.
But sometimes the things that the setup enables, because of the algebraic structure that you're creating here, means that we can do many great things in cryptography later. What we've seen is there have been other setups in the past, not specifically, for example, for the curve we care about. So Ethereum already uses BLS 12381 as its curve for BLS signatures for validators in Ethereum proof of stake. It's already in a lot of the clients, and we have really robust implementations of the software. We've done some optimizations under the hood where we care very specifically about having a set number of points. So lots of these previous powers of tau setups have, for example, 2 to the 20 odd points. And we specifically can have, in the case of what we're using for 4844, initially is 4,096 points. If there was 4,097 points, there are actually ways we could break the cryptography. And the reason this is true is we're skipping some checks. So one of the things that you see happening a lot in proving systems and in the ZK setting is called degree proofs, which is you basically checking that a polynomial is only so big, that there isn't more data hiding somewhere, or that this is the end of what was committed to. And the way we ensure that this is the end, instead of checking, you can prove it's the end, but instead of checking it's the end, we just like there are no more points. So instead of having extra points where you could cheat the system, you run out at 4096, and then we don't have to do this proof every time we need to use this commitment device.
That's a really good point, because like when I'm reading papers, like let's say all the new lookup arguments, they sometimes, let's say, skip the part where they add degree checks, because they say, you have a setup of the required size, of the size of the table that you have. And this is basically exactly what you say here. You don't need to do the degree checks if that's all you have.
In that case, though, is the output of this very much only for the use case you have in mind, or could other teams use it?
Other people could use it, but it's going to be unlikely to be useful outside of a KZG commitment setup. You're not going to use it in a general snark just because it's too small, unless you have some very tiny snark you wish to use it for. Because of this optimization, because we've done this, there isn't actually one set of powers that we're calculating. So the ceremony, if you dig into the files or the specifications, it's actually 4 ceremonies pretending to be one. Where we're running 4 mini trusted setups for different numbers of powers. So 2 to the 12, which is 4096, 2 to the 13, 2 to the 14, 2 to the 15 powers. And the reason here being that if 4844 ever has larger demands down the line, we can then change the setup we're using to one of these other ones which we've run, where we have more powers available, but again, run out exactly when we need it to run out, so we can skip these degree proofs. But by having these 4 ceremonies in one, we sort of like cheat and get around these
possible futures.
Yeah.
You wouldn't have to rerun it then. Like you would be able to use these outputs for a future. Okay.
Yes. And this is, I'm going to say it's updatable, but that seems a bit ridiculous to say because it's almost trivially so. We can always there's very little that's going on here relative to some of the other requirements you might need for a snark setup or something like this. This really is a trivial construction.
I think the other reason why it's important for us to run our own ceremony, for example, if there was something else that could slot in exactly, if another blockchain had run something and it happened to fit our use case exactly, I still think we would want to run our own for a couple different reasons. The main one being the Ethereum community possibly hadn't participated in that ceremony. And so the trust assumption is you need just a single honest participant. But if you, as a general member of the Ethereum community, didn't have an opportunity to participate, you have no way of verifying that the assumptions of how this other ceremony was run, you don't know necessarily how the code was written. Not that anybody's really necessarily digging into our setup, but
Kobe
they
is.
at least right. Kobe is, but the average contributor is just opening the browser and they'll add their entropy and then go on about their day. So yeah, this goes back to the idea of like building consensus and specifically in the context of a specific community. So everybody has the opportunity to actually participate in something that's going to go directly into the protocol, and you can be sure that if you're using Ethereum, if you're using the Ethereum network, that you can verify that your contribution was included, and at least you know that you were honest and you discarded your secret. That's another reason why I think is important.
Yeah.
That actually makes sense. So it's funny, we have not mentioned the term multi-party computation yet. But just for listeners who are familiar with that is what this is. And that's that idea where if one participant is honest, then one can be assured that the output is correct or is protected. But in your case, you kind of mentioned that you felt like the Ethereum community had not been able to participate, but like Tornado is pretty Ethereum focused. I guess you weren't able to use the output of that anyways, so you had to kind of redo something like this.
Yeah, so it ties into that. I think many of us have participated in these previous ceremonies, not only for Ethereum, but for other chains and protocols. But not, I think, many people in the wider community, I think, is one of the issues here. And then the second thing is, again, because we have this like very important trust assumption about the running out of points at precisely the right time. If we use another setup that is longer and we use it as a start, right? We'd build on top of it, which is something you could do for if they had an updatable setup or something like that. If we were to use that and their ceremony was bigger, then that violates our trust assumption already. So like it's already not particularly helpful and would already allow you to, like it's not adding anything if you can't verify that it has this property of running out of points precisely when someone dishonest would need them.
Yeah. I would maybe challenge that a bit in the sense that you could always like take the chunk that you need and build on top of that, and then you would gain something. Yeah, I think those are all like extremely convincing points to me.
Yeah, no, I agree. It's not quite as simple as that. We actually spent lots and lots of time debating this over the previous few months as to like where should we start for some of these exact reasons. But it's also easier just not to have any questions about where do these like funny numbers come from or whatever. Like the numbers when the ceremony started, every secret was 1.
That's perfect.
And you could check that yourself as like, yeah, it's easy to have that argument.
Nothing up my sleeve, right?
Exactly.
Also, compared to other setups, I think that the KZG ceremony team or group that was working on it put a lot of emphasis on creating multiple implementations or like creating a spec that anyone could implement. And that also seems like a really appealing point in enhancing the trust in ceremony, right?
I think this is something we've done that's quite radically different. So with Ethereum proof of stake, this was all written with these specifications first. And so there wasn't any like more enshrined client over any of the others or that kind of thing. Myself and many other researchers at the EF and wider ecosystem were writing specifications, and then other people implemented those. And we learned a lot from that, and from the perspective of how it enables more people to easily understand what's happening, which I think is important in a proof of stake or in a consensus protocol, but also really important for these ceremonies. You can explain things in normal natural language. You don't have to implement optimizations in these specifications. It just says like, here's what you need to do, which I think is really beneficial. And then the second thing is this allows for a lot of clients to exist. So we started the ceremony, like there was no other code asides for like what the specification said. So we started this whole idea with these specifications, and from there like encouraged many people to write implementation. So from almost day 0, we had multiple implementations of this code, and like we're seeing more and more pop up as the ceremony progresses, and we're really trying to encourage more people to write.
Is there a ChatGPT based implementation yet?
Not that I know of.
Okay.
That's quite unique for these types of things. Is it the first time that happens, that there's like multiple clients or multiple implementations of a trusted setup software?
It's the first time where there've been multiple, to my knowledge at least, it's the first time there've been multiple viable implementations. In many other cases, there've been people who have modified one of the other clients that exist, or written their own crypto components, or sometimes even reverse engineered and written their own implementation to like help convince themselves that this is secure under like similar premises. But I think this is the first time where it's been this like multiple client first approach, where there's like, there isn't a canonical way of approaching or of contributing or anything like that. We really want people to sort of find their own path a little bit here, and ideally have as many different clients implementing the software as possible.
It sounds so directly inspired by just the way that like the POS, like all of that had happened, where there was multiple client teams building off a spec, sharing knowledge. Is that sort of now built into the philosophy of a lot of builds like this? If the community has to come together, there's always going to be an attempt to get a lot of different teams building the same thing.
I think it's definitely a good thing to aim for. And we'll probably get into this later, but we're also very lucky that it's pretty straightforward and simple to actually write an implementation.
Okay.
For example, like later we might talk about like how many contributions we have currently and how many we expect in the future. A lot of this comes down to the fact that it's a very small amount of computation that you have to do. Similarly, creating a client implementation is, I mean, Carl has said like you could do it in an afternoon. I don't know if it's that quick, but it's a lot faster than writing, some of these other multi-phase ceremonies.
Got it. How many contributions have there been so far, and how many do you expect? I mean, maybe we can actually talk a little bit about like what you've also learned along the way. What's worked? What broke? I'm really curious to hear.
So I have the dashboard up here. As we talk, we have just under 7,300 total contributions. Which I think might make us the largest ceremony ever so far.
Already.
In terms of number of contributors, I guess. Yes.
Right. Yes.
Right.
No, not absolutely. In terms of number of contributors.
I think we did the longest running, possibly.
Yeah, and like the biggest curves, you know.
Forever. Yeah.
And while we're like going through this, and I'm realizing like, oh, we have a ton of contributions, but it's not necessarily, you want to be able to compare these things apples to apples. And so I was thinking of like, is there a metric where you can combine like the total amount of compute time and the number of contributions? Because, yes, it's nice that we have a really large number of contributors, but we're just lucky that it's a tiny computation. Other ceremonies, it's super impressive that they've been able to get the number of contributors that they have with, when they're passing around multiple gigabytes and you have to schedule. It's much, much more intensive. For us, we just have this website and people show up to it. So we're very lucky in that sense.
Yeah, but you are right, like that, in the amount of trust that you need to have in this ceremony is much less because, like you say, just need 100 participants, and if you have 7,000 already, then you're really in a good shape. So that's nice.
Yeah, I think it's actually something that's changed over the years in terms of like what ceremonies mean or what trusted setups mean. And that's the emphasis on how much trust is needed. In the beginning, there was like, it really was trust these 6 people in a room.
Yeah.
And now we're at the point where it's like trust 7,000 odd people. And I think that's got a very different meaning because at this point, like it's not that you have to trust someone to do the right thing. It's that you have to trust not everyone to have like pulled apart the code and like figured out how to extract the secret themselves. Because like most of these implementations don't just show you your secret; they like do some extra hashing and randomness mixing, etc., etc. So it's like many extra steps, and like after that, you need everyone to collude. So already at the current point, I feel like we're getting very quickly to the point where it's like it's not really a trust thing, and it'd be very unlikely that everyone were to get together to reconstruct the secret. And we're shifting to a realm where it's more about like, are there common bugs in all the interfaces, or is there a mistake in the ceremony, in the cryptography, something like that. It's like the trust model is changed a lot over time.
And I think that's why, crypto, our industry is notorious for redefining existing terms or, misusing existing ones. But I think that's why we've chosen to lean so heavily on ceremony and not trusted setup, because this is very different from this ain't your daddy's trusted setup kind of thing. Like this is very different from 6 people in a hotel room in Colorado. This is everybody can participate. It's relatively accessible. You just need a browser and some time to keep checking the page.
Tell me about like some of the learnings, like the participants. Like I'm guessing they're creating entropy, like you said, kind of randomness on their own. Are there any like cool examples? Are people meant to share this somehow? Like how they got it? Obviously not share the random number, but like share their method.
So the interface we've gone a little bit beyond what's like the base case, the bare minimum of what you would need. So we have 3 sources of entropy if you're using the web browser. So you're moving around your mouse and the interface is taking snapshots of your mouse cursor at certain points in time. Mm-hmm. You also input some text entropy, and we encourage people to either do keyboard mashing or include random characters so that they don't remember it. And then the last one is the browser actually generates it locally, generates some randomness locally in the background, so you don't even see this part of it. So maybe we'll get into exploits later, but if somebody really wanted to compromise their contribution, they would have to pick apart the interface and withdraw or like take out all 3 examples of entropy that they've crafted. The sapling setup I always reference this example of they went up in an airplane and measured radiation from the Chernobyl piece of cloth, which is very evocative and like a really awesome. We're not expecting everybody to get to that level, but yes, we are seeing a couple cool examples. Like somebody is making a cat toy and then playing with it with their cat and then extracting the randomness from that.
Cool. Have there been any hiccups in the rollout of this?
No, in general, it's gone fantastically. Like really, there were so many ways that this just hiccups. So, I mean, we've tested this a bunch locally, and it's been audited separately by multiple people. But it's very different that from actually testing it with thousands of people actively trying to get involved. So from that perspective, we're really happy. One thing that has been interesting to see is we've employed something a little bit different to most ceremonies, and there isn't a queue to participate. So when you would like to join, use your whatever interface you're going to do it, be it one of the hosted websites or a CLI interface, et cetera, and you sign in with either an Ethereum account or a GitHub address, a GitHub account, and from here you go to contribute, and you get put in what we call the lobby. And the lobby is you and everyone else who's trying to contribute at the same time. And then what everyone does is it says like to the sequencer, hey, how about now? Like, can I contribute? And the sequencer's like, nope, someone else is already contributing. Yeah, cool. And then you come back 30 seconds later and you're like, okay, what about now? And so everyone is like constantly asking the sequencer if they can have a turn to contribute. And so I think a lot of people have been butting up against this thing where there's this notion of a lobby where you can be in it for quite a while, where the lobby is like, as you're currently speaking, is almost 4,000 people trying to contribute next, and you can be in quite a while waiting, and it's not necessarily a queue, so your wait doesn't necessarily get shorter over time. It's like a constant chance of you being included to contribute next.
Oh, wow. Okay. Like the people in the lobby are not in order.
No.
They're just
Right.
pinging randomly and one of them's going to get accepted. So there is a chance that you just enter into the lobby and immediately get to contribute.
Yeah, and we've had people who like, we've had a bunch of people complaining because they've been in the lobby for a while, and then others who'd be like, oh, I just rocked up and it was like a 5-minute thing. Thanks, this is also great.
A range of experiences.
Okay.
Yeah. Managing expectations around that has been, I think, something we could have done a bit better, and explaining what's supposed to be happening, and the fact that waiting here is not something that, like, if the lobby's big, you should just go away. Like, come back later. That's not nice to hear, but that's kind of just the way these systems work. And I think this has been the source of a lot of frustration for a lot of people. And then the second thing is like the way most people seem to be contributing, because it's just the quickest and easiest, is via the website hosted at ceremony.ethereum.org. Because that's a browser implementation, browsers aren't used to like constantly staying online and like speaking to another piece of software, in this case, the sequencer. So when like browsers aren't very good at regularly checking in to be like asking at the appropriate time, like, hey, can I contribute now? So we've had some like desyncing errors, or like the computer puts some tabs to sleep or something like that. So we're still trying to like get to the bottom of all of those, in terms of what's happening there. And that's like accentuated by the fact that you could be waiting a while because this lobby is currently pretty big with lots of people trying to get in.
Has the sequencer had any trouble? Like, could the sequencer go down at some point and need to be restarted?
I really hope not.
Okay, that would be bad.
Yeah. I mean, it would be bad from like a UX perspective and a thing. It hasn't gone down, and we've like rarely chose a beefy machine to run this on.
Okay.
When we're discussing like what resource do we want, it was like basically what's the fastest machine with the most cores, crazy amounts of RAM, and the best guaranteed internet connection you can get. So it really is a powerful machine. So we haven't seen anything there. But like one thing we have found, for example, is the upgrades. Like, so the sequencer, we can improve the experience. So right now, if you have one of these hiccups with your browser or something like that, you get logged out and you have to go back to the start and like sign in with Ethereum again. And that's like not a very pleasant process. So one of the upgrades we have in the pipeline is to basically be able to keep you logged in. So the sequencer will just mark you as being in an idle state. And then when you start, your browser comes alive again, it will then like take you out of that idle state, which I think will be a lot better UX for many people.
Does the browser have to be open and visible, and that you have to do something once you get into the position to contribute, or is it automatic?
So that's all automatic and happens in the background, but exactly like what the browser needs to do, we don't really know, because different operating systems and different browsers do different things in terms of putting tabs to sleep.
I see. Okay.
So like I would recommend having it like maybe in the corner of your computer or like something like that.
And like checking in on it, maybe.
Yeah, I'll try not to open 20 tabs in front of it. But I mean, again, if that does happen and your browser does go to sleep, we can always bring it up again. But I mean, so one of the things I was trying to get to earlier is like in terms of you asking about hiccups with the sequencer, is in order to implement this change where the sequencer doesn't immediately log you out, we're going to have to restart the sequencer, which is going to kick everyone out of the lobby.
That's what it would do. Okay.
Yeah, so it's like a little unfortunate that like it's going to be, if we were to do it now, 4,000 people who have to like leave and come log in again. But again, these are like some of the small changes we might have to make everyone's UX a bit better.
Yeah, so the logging out thing happened to me a few times already. and because I always have to move my computer around and like change tabs. So just before this episode started, I started waiting again. So maybe I'll get lucky and during the episode I'll be able to contribute.
That would be cool.
Kobe wants to speak to the manager. He wants to speak to the sequencer.
Aren't I doing that right now?
Yeah. The best we can say is just wait a little bit longer.
Fine.
So I have this question. I mean, when I was putting together questions for this, I thought of asking if this has anything to do with this on-chain ceremony that we had talked about on a recent episode with Dan Bonnet, where the sequencer or coordinator is actually on-chain, if I remember correctly.
Yeah.
And as far as I can tell, this ceremony is not that, right? It is the sequencer. It's still like you described, like it's a beefy machine. It's one machine. It's not like a decentralized thing.
Yeah. So this is entirely off-chain and uses like more traditional web constructions for making all this happen. Mm-hmm. The reason that the idea of an on-chain ceremony is possible is because, again, the sequencer's role is just to decide on the order of things and to decide whether someone's contribution is like actually a valid contribution. They didn't just make something up and say flower when you expect a set of points. So you could do this all on chain and submit it to a smart contract, or you could come up with all sorts of fancy constructions for verifying this, where the chain data basically serves two purposes. One is verifying that things were done correctly, and the second is making the data available to everyone so that you're able to just download it and use it when you want. But the reason this is not super useful in our case is that our ceremony is sort of just too big to be able to fit on Ethereum right now.
Okay. Too big in terms of participants or contributions?
No, too big in terms of like the number of points.
Oh, still? Okay.
Yeah, so although our ceremony is like super tiny, and like we keep getting all excited about this, it turns out that like if you look at Ethereum's just like even more slow than the sequencer is tiny, or that the ceremony is tiny.
Okay.
It would have overloaded the gas limit, right?
Yeah, so if we just do like the call data for 4,096 points, it's like just bigger than a full block. And I mean like full as in 1559 full, like 30 million gas in a block. So it doesn't fit in a full block, which means like the cost of contributing would be very high.
And we'd be taking capacity for the entire network for like 4 months, which is probably not endearing to people.
Would this ceremony be able to be run on a roll-up then? Like, or on another L1, like where it isn't a constraint?
Possibly. And this is actually one of the really fun things I realized a while ago. And that's that. So the thing with rollups is they need this data availability. They need to guarantee this data. And that's in essence like they need to put this data somewhere. And that data in the case of Ethereum is on like the Ethereum base layer. And that's like the whole point of this dunk sharding and 4844 approach is to provide more space for that. But if we just use Ethereum as it stands now, the rollups run into the same problem where it's like if you were to use a rollup, it could do the computation really efficient, but the data itself still wouldn't fit inside a single block. But if we had 4844 deployed, then we would have the space to do this. So it's
funny.
this recursive problem, right? Like how do you bootstrap having enough space to start this? So in the future, if we were to like rerun the ceremony, there is a chance we could do it on chain, assuming like the rollups weren't using all the space, et cetera, et cetera.
Oh, interesting. Okay, I think this is actually a good point for us to start talking about like why you're doing this ceremony at all. You've mentioned this EIP 4844, and I'm assuming this is what this enables. But yeah, can you explain what that is and how you need this SRS, like why you need a trusted setup to enable that or to work with that?
So to understand EIP 4844, you need to understand like Ethereum's vision for scaling moving forward. L2s are the vision we see for Ethereum moving forward in terms of providing lots more compute for everyone to be able to fit their transactions and NFTs, etc. on chain. But compute is useless if we don't have the storage to back it up. And L2s have this problem where in order for like their trust assumptions to remain true in terms of like what happens when there are malicious people, malicious sequences on L2s or something like that, this data needs to be provided somewhere else. And it needs to be provided with a level of assurity that a sequencer on L2 simply couldn't provide. So what the sequencer, an L2 sequencer does is they take all this data and they put it on Ethereum, on the Ethereum base layer, on Ethereum L1. And this works great, but now we're having these like L2s massively scaling the compute for Ethereum, but they're starting to run out of space. And the costs then for the L2s, be they ZK or optimistic, the costs for them start rapidly growing when they have to put more stuff in the blocks than there is space in the blocks, etc., etc. So the idea behind proto-dank sharding, also known as EIP 4844, is that we have a bunch of data next to the Ethereum chain that is broken up into blobs. And we call them blobs because from the chain's perspective, we don't really know, understand, and or care what's in them. But it's just an arbitrary amount of data. And EIP 4844 uses KZG commitments to commit to this data, so that it is like we have a proof, much like you could use Merkle trees for state in traditional blockchains or Ethereum right now. You do a similar thing, but with this new commitment device. And then later on, if anything goes wrong with the rollup, the rollup can prove things about this data. So these blobs make this data available to everyone. So data availability is something that's discussed a lot. So the validators who are looking at the current state of the chain check that the data really is in these blobs and that they were able to download it and it's available for everyone. So if you're using an L2, you want to see that your data made it into one of these blobs, and you can download the blob yourself if you really want to make sure you have it. And then if the sequencer on an L2 tries to cheat you or a ZK proof fails, etc., we can go back and find out, like, here's the data to prove what did or didn't happen. And that's sort of the vision for scaling Ethereum now.
Yeah, I want to ask you something here. First, I want to just get a clarification. You said the KZG commitment. Is that what you called it? Like,
yes.
So you said the KZG, it's like this whole ceremony is for commitment. So it's not for a snark, is it? Or is it a snark? Like, I think this is where the terms you're using, I'm just curious if it's like, in this case, the ceremony, the whole thing, is it just for this commitments and it's not really a full snark?
It's not a snark. It's purely for committing to data.
Okay.
So you could view as a snark as committing to computation.
Yeah.
In some ways, and this is doing a similar thing. And the reason we use this over like some of the other commitment devices that we've seen, as I was saying earlier, Merkle trees, or maybe so Merkle trees wouldn't work, for example, because they become quite expensive to prove in snarks. So if you have ZK rollups, now we're trying to offer them this data. If they can't prove things about this data, it becomes very hard to reason about. So that's why these kinds of hashes wouldn't work. We could swap out a SHA hash or something like that for an arithmetic hash, which would be more favorable inside a snark. But then one of the other requirements we have is for the like future visions of where we'd like to take all of this, all these data blobs, is to take them and extend them out using erasure coding. So we take each amount of data and we like massively extend it, and we commit to that extension. And the way we do that is by fitting a polynomial through it. And this polynomial happens to we can use the same cryptography that KZG relies on under the hood, which is also like commits based on a polynomial. Hence why they're powers in the powers of tau that we're using, right? Like a polynomial C x squared, whatever. It's the same thing we have that are the powers in these powers of taus. So that's like the sort of commitment device that we're building here. And the fact that there's this like synergy between our like future visions for how we would like to commit to data and extend this data, and ultimately do data availability sampling, which I can touch on in a moment, it would require these polynomial extensions anyway. So we're using this cryptography or similar things anyway. And then this really just like is a cherry on top that it's the same thing and worked really well with that.
Yeah. So actually, I have a question about 4844 itself, because you're creating KZG commitments on BLS12 381, and you put it as data blobs that are not easily accessible to the rest of the chain or to smart contracts and others. And also, like, there are no precompiles to use BLS12 381. Like, there is this long-standing 2537, I think, that wasn't deployed yet. So how can people actually use 4844 on chain, or is this purely for data storage?
So I mean, the answer is that we need to get that EIP merged or included. I think everyone's on the same page there. It just hasn't reach the top of priority lists of client developers, because it is very useful for that, also for verifying the signatures we have, and could be used for some other fun cryptographic things. So definitely need that. The way the 4844 vision works is sort of twofold. It does two jobs. One is first making sure that data is available to everyone.
Yeah.
When a new block is proposed with all the side data, all the validators go and download it and check that it's available. And only if it's available do they attest to it, which is like part of the roles of a validator, attesting to things. And so this allows us to like ensure that this data is there and allows like end users to go download this data. But then in order to like prevent the state blowing up for these validators, otherwise you just have like more and more data you have to look after, these validators are actually allowed to forget this information after a certain amount of time. So you can just delete blocks that are older than a certain amount of time. This allows the validators to have a constant size database that they care about for these data blobs. And then users must download this data that they care about. And the sequencers on all these L2s will download this data. And then the second role here is like if something goes wrong in an L2 and we need to start having fraud proofs, or like we need to have debates basically and resolve things as to like what reality is, things need to be then proved against these KZG commitments.
Yeah.
So if I say like something went wrong and the sequencer stole my money or something like that, I have the transaction I downloaded a week ago, whenever, when the transaction actually happened, and I saw that data blob go on chain. And then I go to Ethereum main chain and I say, here's the data. I would like re-provide the data because the chain might not have the data anymore. I re-provide the data and the KZG proof that this is the correct data. And from there, we can verify like this commitment was correct and like resolve this conflict.
So do I understand correctly in that case that like 4854, I think I saw that it includes like a point evaluation precompile?
Yes, that's correct.
Okay, cool. It's because I think I saw that the Scroll team was planning to use this. Like they wrote a blog post about how they would show that the commitment that they get from their snark, which is on BN254, and the commitment that you get from the data blob, like they would use this proof of equivalence to show that basically they committed to the same data, which in their case would be a list of transactions. Do you know if that's like the common use case for rollups, how to use this, like to show that the list of transactions were included or the data in transactions?
I mean, so from a like protocol designer perspective, I get to like wave my hands and say like that's up to the rollups. But my understanding of the landscape as we speak is like, yeah, that's basically what will happen. And like what is the intention of many things is basically a list of transactions.
Okay, cool.
And potentially the proofs to go along with them in the ZK setting. One of the interesting things is that when, like based on Ethereum usage right now, there's going to be so much data available when 4844 launches that we're expecting people to just do silly things and like throw memes on chain just because you can, because data is going to become really cheap again. I mean, it'll be temporary until rollups scale to use this, but it'll be fun to see that landscape play out.
Going back to the ceremony, I just wondered what happens if, and I know like there's already 7,000 participants. Everyone's created they've added their own entropy. But what if somehow the toxic waste of this ceremony was discovered? What could anyone actually do? So you talked about it's for KZG commitments. Like what could it break? What could some malicious actor actually do if they found that collection of entropy that you're not supposed to know, the private stuff?
Right. Maybe I can the context is like, they would have to extract every single contributor's
I know.
all three forms of entropy.
I get it.
Just for context for people. It's very unlikely. But if they did, they could forge fraud proofs, I believe, for L2s committing back to L1. And that would be bad.
This would only work for like the optimistic type things, or is it?
If the toxic waste is discovered, it allows anyone to make like arbitrary arguments about what data was committed to in 4844 in these data blobs. And so in the context of L2s, this could mean that you could lie about the transactions. And with optimistic rollups, you could then say that different transactions were included. And no one would have any on-chain way of proving that this wasn't the case. And in the ZK setting, you could say that, oh, like maybe the ZK has like, here's the proof that they committed to. You could say, here's a different proof and submit it. And it would like also look equally valid to the chain. So like you lose the ability to like uniquely commit and prove to things that happened. So it really becomes the Wild West in terms of L2 like data security after that point. And at that point, we require social recovery to get us out of that bind, because that's like is really terrible from an L2 standpoint.
Okay.
Yeah, exactly. So I think like maybe if we could invent a scenario even for a Zika rollup, you could lie about the fact that the data is available and you will not be able to replace, let's say, the sequencer or others, and people's money might get stuck until you've like figured this out socially.
So the data availability is an interesting one, because that's the job of the validators. And so like you'd still have to be providing data to them. You could be providing fake, you could lie about what the data really is and change the data after the fact, but you still have to provide data. And when we switch over to full dunk sharding, then like every node on the network, not only validators, would be sampling this data to check that it's actually there.
So there is one case that I can go into. Obviously, it's very unlikely that everyone has leaked their entropy and, you know, decided to collude and corrupt the ceremony. But there is a case where, you know, we go through this many months of contributions, and then there's a final output, and then Carl turns malicious or something and decides to, you know, output this faulty or corrupted version of the ceremony, which he claims is a ceremony, but actually isn't. And then, you know, in this scenario, the client teams are also like, we trust you, Carl. Good job. Thank you for this output. And then they put it into clients without doing diligence. So one small step that we can take in advance of this actually being included into clients is this social signaling around, okay, the ceremony is done. Everybody is going to signal that they've run some verification script, that this is the output that we're all expecting, that we were all included in. And yes, okay, we're all thumbs up, good to go. And my contribution is actually in this transcript. So that'll happen, you know, after this special contribution period, or sometime between the end of the ceremony and before client releases are actually cut for whatever the upgrade is that includes 4844. So that'll be really important when it comes time. You can do this now, but you're checking it against the current state, not the end state of the ceremony. So when that time comes, I encourage everybody to, you know, not just do your part of contributing to the ceremony. That's step one, but step two is doing this, run a script locally, and okay, yes, I've verified that my contribution is included.
Interesting. But participants don't have to. This is more just like you're going to encourage a lot of people to come back and check it.
Right. You don't have to, but it's sort of part of this whole, like Carl mentioned earlier, of like, once we get beyond, you know, X thousand participants, you're only improving the credibility of the ceremony in small degrees. And this is one way where you can improve the credibility of the ceremony, is having many people attest to the output of the ceremony as being valid and credible and legitimate.
Cool.
One of the cool extra things here is that because we're using people's Ethereum addresses to like verify like as some kind of anti-Sybil attack mechanism, we have a built-in signature scheme, as in you can sign messages with your Ethereum account. And using this, like you sign your contribution as well. So you could see that like Anna.eth was contribution number 67, whatever. And because you can verify this and there's a signature there, as long as I trust you to also have control of your Ethereum account, I can verify that this was your contribution. So there's like additional levels of verification that we have built in here, which is you sort of get for free by having people use their Ethereum accounts.
Do you think there's a lot of like farming happening? This seems to happen with a lot of these projects where it's like, even if there's like no promise of an airdrop, no sign of an airdrop, there's nothing, but people are just like jumping in mass. And so they won't just run once. They wouldn't just like run this once, but rather run it like, I don't know, 100 times. Are you noticing this? Is there anything you can do to like stop that?
A little. Like I've seen a couple indicators that maybe some people are, you know, pursuing that path. At the end of the day, it's all good entropy. This is all stuff that will only help the ceremony, unless it's like, you know, somebody colluding with this specific intent to, you know, keep around their secret and then try and corrupt the ceremony later on. Did notice a bit of it, it seems, happened with the recent Namada ceremony.
Yeah.
We'll see if that ends up being the case for ours. It's definitely, we weren't expecting this level of attention this early. So this kind of plays into the issues of like, we have some troubleshooting and the lobby wait time is really, really long. It's a good problem to have. But we definitely weren't expecting this amount of attention, in the first 3 or 4 days.
By the way, I don't think it happened with Namada, but I think it like people were trying to, right?
Right. Sure. Yeah.
Because theirs is actually quite coordinated. Like,
yeah. They had tokens and things. But the other safeguard we have against this is that we do have a cutoff of you had to have sent, if you're using Ethereum, address as your anti-Sybil login. If you had made 3 transactions before Friday last week, the 13th, that's our cutoff point. So you can't
go back.
There is,
yeah.
Right. You can't just start like farming a bunch of addresses now, send a bunch of transactions, and then use that as a legitimate account. So we do have at least that safeguard.
Okay.
However, that won't stop somebody who's been doing stuff like this for years. Right. Yeah. If they've been farming, they're going to, they'll have it.
They'll have it set up.
This is something that we've known and expected. And part of like the discussions that Trent and I have been having and have happened after the last while with the community is like, where do we set these constants at? Like, how do you decide that like having sent 3 or 4 transactions in the past is the right number? The decision here was to rather keep it on the lower side, to be extra inclusive and have more community members, particularly people who may have only joined after the switch to proof of stake for moral energy reasons or something like that. Like just to try and have as many people contribute as possible, at the cost of having more people like potentially try just contribute multiple times, etc. And we're like very okay with that, and that's part of the design of the ceremony. Rather err on that direction than excluding people from participating.
Cool.
I was looking around at the JSON that the ceremony sequencer returns, and I saw like parameters that I wasn't expecting. So you mentioned that you bundle a few setups in one here actually, but from what I know, if you do like KZG and you skip the degree checks, then you don't need more than 1 G point, let's say, in every setup. So how come you have 65 of them in the ceremony?
You're right, we don't. It's more of an in-case thing. They're so cheap and almost free to include. Like 65 is such a small number of G2 points that we decided just to include it in case someone finds a use for it later.
So what 65 points are there? Like you have thousands of G1 and 65 of G2. So what is the structure of those?
It's the same powers of tau. So it's just reflecting those increasing powers just in G2.
Okay. I mean, they're just like so much less, right?
Yes. But again, as I say, we don't really have a use for them. It's just in case we decide we could do something fun with it later, or in case someone else comes up with a use case.
Very interesting.
Cool. So you've told us that like the plan for this is a couple months, and then it would be included in the next update. But like, what is the time frame for 4844? Like, what do you, maybe you don't want to predict it here, but like, what's the larger trajectory and roadmap for this?
Yeah, giving timelines always backfires, but withdrawals is the next main focus, and that'll sort of complete the loop of proof of stake and give us a full proof of stake functioning system that people can enter and withdraw the participating in validation. But once that's done, and there are dev nets currently and client releases hopefully in the next few weeks, and then that'll move into testnet upgrades, things like that. Once withdrawals is done within the next few months, then a lot of people have signaled that they're very interested in seeing 4844 be really hardened and implemented in clients. There's already a ton of ongoing work currently. So one thing that we've been really fortunate to do over the last year or two is start to develop parallel tracks for contributors. So the merge was ongoing and people were already working on 4844. Same thing with withdrawals, getting the initial spec going. So 4844 has been in development for a while in terms of like ideation and client prototypes, things like that. It's really exciting to be working on core protocol Ethereum at this time because we can start to parallelize these massive upgrades and big changes to the protocol that will bring significant benefits. So once withdrawals is done in the next, I won't give a date for that either, but the big focus directly after that is the next upgrade, Cancun.
That's what it's called.
Pessimistically, that would be Q3 of this year. Yeah.
Okay. So I want to say thank you to both of you for coming on the show, sharing with us the KZG ceremony, how it works, what it's for, and how it's going. Yeah, thanks so much for that.
I'm still in the lobby. It only got larger.
Oh man, I'll see what we can do. I'll pass along your request.
No, it's fine. I'm happy to wait.
The lobby seems to be most empty at midnight UTC.
Okay.
Yeah.
And it's slowly, I think we've peaked in terms of attention these first few days, and it's slowly balancing out, but that's still like several thousand people in the lobby. So maybe wait a week if you really don't want to like babysit your tabs, and then you'll have a better time of it.
Sounds good.
Thank you for having us.
Yeah, been fun.
We should also give a thank you to everybody else besides us who worked on this. It's not the Trent and Carl show. There were probably 24 people involved in various aspects of this, and the project wouldn't have happened without them contributing to the front end, the interface, working on the actual crypto that runs in the background, working on the sequencer, the people that worked on the audit. So I won't list them all because I'll probably forget somebody, but a massive thank you to everybody who put in time and love into this project.
Cool. All right. I want to say thank you to the ZK podcast team, Rachel, Henrik, Tanya, and Adam, and to our listeners. Thanks for listening.